Measures of position. We'll start out with percentiles. We'll be mostly working with percentiles and quartiles as measures of position. The p percentile is a data value that is, roughly speaking, larger than p% of the data. For example, the 38th percentile is a data value that is, roughly speaking, larger than 38% of the data. Different texts have different ways of computing percentiles, you may get a different answer depending on which method or which text you're using, especially for the smaller data sets. But anyway, I'm going to go over the method that we will be using. So I'll give you an example. We have 12 exam scores and 80, 88, 28, 91, 65, and so forth. And we want to use these to compute percentiles. And for any kind of measure of position, the first thing we want to do is rank the scores from smallest to largest. So the smallest score, 28, we have rank 1. The second smallest, 28 is rank 1. Second smallest, 59 is rank 2. Third smallest, 65, that's rank 3. And then fourth from the smallest is 78, that's rank 4. And then we have an 80, that's rank 5. 82 is rank 6. 83 is rank 7. We have two scores of 88. That would be ranks 8 and 9. Oops. There we are, 88. 89. In rank 10 we have an 89. And then rank 11 would be 91. And the highest score, rank 12, 92. Okay, so the formula that we're going to use, okay, so part A, we want the 20th percentile, or P20. The formula we're going to use is n times P over 100. So we have n equal 12 exam scores, a desired percentile, P is equal to 20. So that's the rank, desired rank is going to be 12 rather times 20 over 100. That's 240 over 100, which is 2.4. And for the percentiles, 2 point anything, we want to round up to the third. Round up to the third. So yeah, our usual rounding method for this course will be round to the nearest number. So 2.4 we round to 2, but for percentiles, we want 2 point anything, we want to round up no matter what to the next number. So and then we take the third rank score. The third rank from smallest to largest is 65. So our P20 or 20th percentile is 65. So roughly speaking, 65 is more than 20% of the data. It doesn't. The percentages don't quite work out for this data set because of the small number of scores that we have. You're not going to get exactly the 20th percent. None of these numbers are going to be exactly the 20th percentile for any of these scores, but this is as close as we can come. So anyway, we're going to say P20 is equal to 65. Okay, so now there's some special percentiles. One of them is P25. P25 is also called the first quartile because if a data value is more than 25% of the data, it's also more than 1/4 or 1/4 of the data. So P25, the 25th percentile, again we'll use the same formula, n times P over 100. We still have 12 exam scores, n is 12, P is 25, so 12 times 25 over 100, and that's going to equal to 300 over 100, which is equal to 3. So the way we're doing percentiles, and again, different books do it differently, if it comes out to be a whole number, we want to take the average of the third and fourth rank. Take average of third and fourth rank scores. That's whenever it comes about the whole number. Ranked scores. So if we have 3 point something, 3 point anything, we would just take the fourth. But if it comes out to be 3 exactly, then we take the average of the third and fourth rank scores. So if we go to our list of scores here, the third rank is 65, the fourth rank is 78. So it's going to be 65 plus 78 divided by 2. 143 divided by 2, 71.5. So our 25th percentile, which is also the first quartile, is 71.5. Okay, another special percentile is the 50th percentile. A 50th percentile is also called the median. It's also called the second quartile. It's more than half the data. It's also more than 2/4 of the data. And so we can use the same formula, n times p over 100. We have 12 scores. P, now in this, for part C here, P is going to be 50. 12 times 50 over 100, 600 over 100, which is 6. And it comes out to be 6 exactly, so we want to take the average of the 6th and 7th ranked scores. If it's 6 point something, you round up to 7th, but if it comes out to be 6 exactly, then take the average of the 6th and 7th ranked scores. So the 6th ranked score is 82, the 7th rank is 83. So 82, P50 is 82 plus 83 over 2, 165 over 2, 82.5. So P50th percentile, which is also the second quartile, also called the median, is 82.5. So that's another way of computing the median. We can use the percentile to compute the median. Okay, so median is a measure of center, like the mean and the mode, but it's also a measure of position. The 75th percentile is another special percentile. That's also called the third quartile. 3/4 is the same as 75%. And I use the same formula here, 12 times 75 over 100. Sometimes it helps to think about money. 3/4 would be, in terms of money, 3/4 of a dollar is 75 cents. That may help you with the, remember the third quartile is the same as the 75th percentile. 12 times 75 is 900. 900 divided by 100 is 9. Again, this came out to be a whole number. If it came out to be 9 point something, we would take the 10th rank score, but if, here it comes out to be 9 exactly, so we want to take the average of the 9th and the 10th rank scores. So the 9th rank score is 88, 10th rank is 89. So it's going to be 88 plus, so when that 9th and 10th rank score is 88 plus 89 divided by 2. 177 divided by 2 is 88.5. So the 75th percentile, which is also the third quartile, is 88.5. Now there's a graph based on the quartiles called the box plot or box and whiskers plot, and the minimum we can think of is the 0 quartile. It's 28, the smallest exam score. And then we computed the Q1, Q2, and Q3. So Q1, 71.5, the median, or Q2, 82.5, Q3, 88.5. Maximum we can think of as the 4th quartile. That's this largest value in the data set is 92. So we want to make a box that goes from Q1 to Q3, and make a box there, and then make a line inside the box for the median. Whiskers go out to the min and the max. So the box goes from 71.5 to 88.5. Make our box here. The line inside the box is for the median, that's about 82.5. The whiskers go out to the min and the max, 92 and 28. So that's our box plot. If you look at where the median is, there's a lot more to the left of the median than there's to the right of the median, and that tells us that the graph is skewed left. Okay. The box plot loses a lot of information, loses a lot of detail, which is an advantage and a disadvantage. So by losing the detail, the box plot is not going to tell you, for example, the number of clusters, but it's very good at telling you skewness. By eliminating some of the detail, it more clearly illustrates skewness versus symmetry of the graph. So the advantage of sometimes it's losing some of the detail is helpful in interpreting the graph. Okay, so for the quartiles, you may see a question about the percentage of data between various quartiles, but there's 25% for each consecutive quartile. So between Q0 and Q1, there's 25% of the data. Between Q1 and Q2, 25% of the data. Between Q2 and Q3, 25% of the data. Q3 and Q4, 25%. That's roughly speaking. So, for example, if you want to combine two of these categories, let's say you want the percentage of data between Q1 and Q3, that's 25 plus 25 is 50% of the data. Or if you want the percentage of data, let's say less than 88.5, you're combining three of these, 25% plus 25% plus 25% would be 75% of the data. Okay, so there's our 5-number summary can be used. We're mainly using it for measures of position, but it can also be used for measures of spread. One measure of spread is the range. It's the maximum minus the minimum, which in this case is it was 92 minus 28, which would be 64. And that is one way of measuring how spread out the scores are. The advantage of the range as a measure of spread is that it's easy to compute. The disadvantage is that one score can have a big effect on the range. So for example, if the 28 were 68, the range would have been 33, which is quite a bit smaller than 64. So another measure of spread that is not affected by outliers would be the interquartile range, and that's Q3 minus Q1. It's a different, and in this case, it's going to be our Q3 is 88.5 minus 71.5, and that's equal to 17. So that tells us how spread out the middle part of the data is, and the interquartile range has the advantage of not being affected by outliers. And we'll get into some other measures of spread a little bit later in the course. For right now, we'll just focus on the range and the interquartile range, but there's a couple of other important measures of spread that we'll get to later. Okay, so let's identify outliers. One way of identifying outliers is just to look at the data, and if we look at the original data, let me see if I can pull that up again. We see that there's a big gap between the 28 and 59, the two smallest scores, and there's not such a big gap between the two largest scores, right? So there's a big gap here, but on the low end, but not on the high end. So it looks like 28, it looks like, just looking at the data, it looks like 28 would be an outlier. So it looks like we have an outlier of 28. You can have more than one outlier, but it looks like we have only one score that's unusual. But there's some more precise methods of computing outliers, and one way of doing it is using the interquartile range. So we want to compute Q1 minus 1.5 times the interquartile range. So the first quartile, let's bring back that page again. The first quartile was 71.5. So 71.5 minus 1.5 times the interquartile range, which we had computed, it was 17. Okay, so 17 times 1.5, 85, 17, looks like 2.55. So 71, no, 25.5, I'm sorry, 25.5. So 71.5 minus 25.5. 11 to 5 is 6. 46. So 1.5 minus 1.5 times the IQR is 46. And the Q3 is 88.5. So 88.5 plus 1.5 times 17 is going to be 88.5 plus 25.5. 0, 1, 6, 14, carry the 1, 11, 114. So so any score below 46 or above 114 would be an outlier. So we have no scores above 114. Our highest score is 92, but we do have a score below 46, which is 28. So so that's another way of determining that, verifying that 28 is an outlier. Another way that we'll get into later in the course is based on z-scores. Z-score below -2 or above 2 is moderately unusual. A z-score below -3 or above +3 is an outlier. We'll say more about z-scores later in the course, but for now we have two ways of determining outliers. We can just eyeball the data, it looks like 28 is an outlier, or we can use the interquartile range, and we came up to the same conclusion. It looks like 28 is an outlier here. And there's a modified box plot that's based on the outliers. Let's see if I can get the box plot here. We have a the box is going to be the same. So we want to use these same numbers for the box. Box goes from 71.5 to 88.5, and the line inside the box is for the median. So we have 71.5 to 88.5 is our box, and the line inside the box is for the median, 82.5, and then we have maximum of 92. And then for the minimum, instead of going all the way down to 28, we're going to go down to the lowest number that's not an outlier, which would be 59. And then we're going to put a little, either an asterisk or a circle here to show the outlier. So that's our modified box plot, and it still looks skewed left. If you look at where the median is, there's a lot more to the left than there is to the right, so it's still skewed left. It's not on this, except for the outlier. If you exclude the outlier, it's not as highly skewed. Does not appear to be as highly skewed as the other one, but it's still skewed to the left. Some books distinguish between minor and major outliers. They might put a little o here for a minor outlier and a capital O for a major outlier. The major outliers would be, instead of using a 1.5, we would use a 3 here. So it would be 71.5 minus 3 times 17, which would be, I think, 21.5. And it'd be 88.5 plus 3 times 17 at the other end. But I'm not going to sort of emphasize that. But anyway, you might see a little o or a capital O, depending on the whether it's a minor outlier or a major outlier. Okay, so that concludes this presentation.